Good afternoon, Gar.
Hi. Good afternoon.
Hi, good afternoon, everybody, and welcome to the Philippine Tunneling Society October meeting, which is held through Microsoft Teams. I'm James Rickard, and the president of the society. So welcome to everybody. I hope everybody's ready for a very, very interesting talk, which will be just start shortly after I announce a few messages. So please be reminded that we do now have a website. It's www.philtunnel.com, and also we have a LinkedIn page, which is the Philippines Tunneling Society. So as you'll see, before the Christmas break, we have one more meeting, which will be held on the 27th of November. This will be another Teams event, and I have a few people interested, but nothing confirmed yet. But if anybody else is interested, then please contact myself or Abby, and we can then consider which presentation we will broadcast in November. Okay, so this is the email address here, philtunnelsociety@gmail.com. So if you're interested in speaking, please contact us through this email address. And also, I'd just like to say thank you for all our corporate sponsors and the members. Okay, as I announced last month, due to the COVID-19 outbreak, the Philippine Tunnel Society Board has decided to extend all membership until the end of December 2021. So if you would like to also join the Philippine Tunneling Society, please contact Abby on the Gmail address we showed earlier. These are the membership categories and fees, which will be issued annually at the end of the year, and it's a BPI account number. So tunnel news, I have 3 bits of news. This one is basically from the same as last month. MWSS has released, shall I say, tender documents for OUTIP number 5, which is a 6.5 kilometer tunnel that connects Ipoh Dam to Big Tay Basin. Also, there's a couple of phases to be done on Mega Manila Metro subway project. Okay, this is basically the first subway project in the whole of Metro Manila, and the proponent is the Department of Transport. So phase 1 is already out for tender or been awarded. There are 4 packages there. The newly released package for tender is CP 104. And then, in addition, there will be another 2 or 5 future packages. The information can be accessed publicly through the DOTR website. So now we get to the presentation for this afternoon. As you all know, it's run through Microsoft Teams. It is a live event, so that means if you would like to ask a question, can you please type the question into the comments box, and then we will answer the questions at the end of the presentation. If we have a huge amount of questions, then we will select the questions that would like to be answered by the presenters. These will be done by the most liked questions. Okay, and also note this presentation event will be uploaded onto our website once it's completed. So we have 3 speakers this afternoon. So I'd like to firstly introduce Brad. Brad's been involved in concrete industry for over 25 years and is a member of the New South Wales branch committee of the Australian Tunnelling Society, and he's very involved, heavily involved in the tunnelling industry. He started supplying and selling fibres for reinforced solutions over 14 years ago with Maccaferri, and now is the aerial commercial manager for Bekaert, and he's responsible for Southeast Asia and Oceania. Brad has been involved in the supply of more than 15 major tunnelling projects during this period, and recently has completed the Northwest Rail Link, Sydney Metro, North Connex, West Connex, M4 and M5 upgrades, and is currently supplying West Connex 3A and 3B, and also in the largest TBM project, which is in Westgate Tunnel, Melbourne. Our second speaker is from Singapore, Mr. Gang, and he is a graduate of the National University of Singapore and has been working in the construction industry for 31 years. He works for Bekaert in Singapore and has been their technical manager since 1998. He also has been involved in a number of underground projects around Asia, including rail and highway tunnels, and also some large underground caverns. He's also been involved in over 50 fibre reinforced spray concrete lining projects and over 15 reinforced concrete precast segment tunnel lining projects. Since January 2019, he is one of the members of the working group drafting the Singapore standards on design of fibre concrete structures. And also in March of the same year, he was appointed as the domain expert for sprayed concrete. And in January of this year, he was also appointed the domain expert for fibre reinforced concrete under the Intelligent National Productivity and Quality Specifications of Singapore. And your third speaker is Jeremy. He is a director of JagCon Properties Limited and is a highly experienced construction professional with engineering expertise in the construction industry, gained on major infrastructure projects including rail, roads, bulk excavation and tunnels. He was recently the construction manager for the stations and mine tunnel works, and Jeremy has led the delivery of all the underground stations at St Martin's Place, Pitt Street and Victoria Cross. Jeremy has developed and implemented construction methodologies that have overcome challenges of operating in the city business district environment, and he also develops innovative approaches to undertaking the permanent lining work in mine tunnels. So I'd like to welcome those 3, and this afternoon they are going to present Steel fibre reinforced concrete for segments in international subway projects. Okay, so Bekaert is a global leader of steel fibre reinforcement and represented in the Philippines by Maccaferri. This talk will cover the recent developments of steel fibre reinforcement in metro tunnels in Southeast Asia and Oceania. It will provide an introduction to steel fibre reinforced concrete, new fibre technologies, design guides for designing segments, and other applications. This will be followed by several case studies in SEA, like the KVMRT in Malaysia, and also the MRT works in Singapore. Then the webinar will finish with the contractor's perspective from 2 recently completed projects in Australia and the Northwest Rail Link and Sydney Metro projects. So that is everything from myself. So now I would like to introduce, I think Brad Boardman is going to be the first speaker this afternoon. So over to you, Brad. Thank you.
Everyone, can you hear me, James? No problems?
I can hear you, Brad. Thank you.
Okay.
It's all yours.
Okay. Thanks for the introduction and thanks very much for the Philippines Tunnelling Society to allow us to present this webinar this afternoon. As James mentioned, there's a lot to get through and some very interesting information to come through. So the first part of the speaking is just an introduction to Bekaert, an introduction to fibre reinforced concrete, and then we'll get into more QA QC of fibre reinforcement and tunnel design with Gung. And as Jeremy said, we'll finish with some great case histories in Australia. Bekaert's a very, very old company, but origin based in Belgium in Europe. We have customs in 120 different countries. We have roughly 28,000 employees worldwide, and our combined sales of greater than $5 billion per year. For us in the Southeast Asia Oceania region, we have 3 key production manufactured facilities, one in India, Loan, one in China, and predominantly all of our fibres come out of Karawang in Indonesia. I guess for the Philippines, it's basically seen as new technology, but in other parts of the world, especially Oceania and America and UK, it's very well used product in drinking water, sewers, datas, electrical, oil and gas, all now use fibre reinforced concrete. We also do roads, rails, and what we'll talk about today is in metros. I guess there's some of you may know there's many different types of fibres, plastic, steel, microfibres. I guess the important point to make is that there's no wrong fibre, just the right fibre for the right application. I guess for us, this is a little bit of our product range, and we'll talk more in general as a general design of steel fibres later on with Gung. But we have 3 types of different fibres: our 3D fibre range, our 4D, and our 5D ultra high tensile fibres. I just wanted to show a little video here which gives an understanding of our application and our product, and how it actually works in concrete. So it's a quick little video.
Concrete is naturally brittle. Typical stresses like impact, fatigue, and loading lead to cracking and eventual failure. Adding reinforcement to the concrete helps to absorb these stresses and to limit the formation of cracks, increasing the load-bearing capacity and ductility of the concrete structure. There are several ways of reinforcing concrete. We've all heard about rebar and steel mesh, but did you know steel fiber is just as strong and reliable? Since its introduction over 40 years ago, steel fiber reinforcement has proven its merits in the most demanding structures and applications. The core difference between steel fiber and other reinforcement solutions is that fibers are part of the concrete matrix, turning it into a composite material. Instead of providing strength in distinct locations, steel fibers form a reinforcing network throughout the entire concrete structure, increasing its overall ductility. So how does this translate into concrete behavior? Take a random concrete structure. When subjected to loading, compressive and tension stresses start to build. Over time, small cracks will appear in places where the stress reaches a critical point. Steel fiber interacts within the concrete matrix, absorbing tensile stresses at any point and in any direction. As a result, steel fiber picks up small cracks much faster than traditional reinforcement. When a crack occurs, the hooked ends of the fibers remain solidly anchored on each side of the crack, acting as a stress transfer media. Once the maximum bond strength with the concrete is reached, the pullout takes full effect. This enables the next fiber to take over, delaying cracks from growing. Different loads require different steel fibers. To meet any design requirement, Bekaert offers 3 steel fiber types: Dramix 3D, 4D, and 5D. Each fiber has a different hook, strength, and ductility. Consequently, they also behave slightly differently when dealing with stresses. Let's take a closer look. First up is Dramix 3D. When a small crack occurs, the 3D hooks firmly anchor inside the concrete matrix. As the stress increases, the hook slowly deforms. As soon as the fiber loses its bond with the concrete, the pullout takes full effect. Dramix 4D provides the same process, but with even better anchorage and a significantly higher tensile strength of 1,650 Newton square millimeters or more. Dramix 5D behaves differently altogether. Here, the hooks never pull out from the concrete. As the stress increases, the wire slowly elongates until it reaches its maximum strength. With a tensile strength of 2,300 Newton square millimeters and elongation of 6%, concrete structures reinforced with 5D can take high flexural stresses over a long period. Based on these behaviors, we can conclude that Dramix steel fibers effectively increase the load-bearing capacity of concrete. It can be used in almost any concrete structure with or without additional reinforcement, where the ductility of your concrete structure depends on the length-diameter ratio of the fibers and the number of fibers used per cubic meter. It is essential that enough fibers overlap to create a continuous network in the concrete mix. Do you need help finding the right fiber and determining the right dosage? Bekaert gladly provides expert guidance through each step of your project from design to execution. Concrete is...
So the important factors here is the high length over diameter ratio, the hook ends, the control pull out of the anchorage, and the tensile strength of the fibers. As designers, they're the most important parts to ensure that you get a high quality product. And what we're here today to talk about is precast segments and why ultra high strength fibers are a very good application for this application. I guess a lot of people have seen conventional rebar, heavy reinforcement, 80 to 150 kilos per cubic meter. Demolding forces, stacking forces, transportation, spalling forces, and jacking forces all are accommodated with this type of reinforcement. I guess the main problems of typical cages is the construction of the cage is very time consuming, very labour intensive. It takes a large amount of space for this operation to happen, and positioning of the cages in the mould is critical to get your quality of the segments. I guess with fibre reinforcement, most of these applications can be handled with fibres only, but predominantly the design requirements or design limitations for fibre reinforcement is the bursting of the segments, which occurs in compression and during installation of the ram bursting. And in some cases, we can totally remove all the reinforcement, but in other applications, when the bursting moments are too large, we can use a lighter cage in the segment. I guess the biggest issue we have is the bursting of the unreinforced concrete section, which can affect your long-term durability of your reinforced cage. There's quite expensive to repair, and a lot of cost involved in that application. I guess durability is a very big issue, and it's something we address quite commonly. And with steel fibres, we don't need the cover that conventional reinforcement needs. We only need 1 to 2 millimetres compared to 30 to 40 millimetres of conventional rebar. Corrosion of the fibres sometimes happens on the surface, but if you see in our case studies, in most cases we don't see any fibres on the surface at all. And if we do get small cracks lower than 0.2 of a millimetre, we do get healing effect of the crack and less issues. And obviously, if you don't want rusting at all, we can use galvanised fibres, but of course that comes at quite an expense. So what are the advantages of steel fibre segments? A high impact resistance, multi-directional reinforcement, dramatically less damage in demoulding and stripping and moving of the segments, and also installation. Fire protection certainly helps with micro polymer fibres, but not so much with steel. We get increased productivity, time saving, reductions of repair costs and damaged segments, and elimination of storage and positioning of reinforcement cages. I just wanted to touch on Jeremy's going to talk about 2 specific projects, but I guess for the Philippines, it's considered new technology, but we're in other countries, we're so much more advanced, and in certainly Australia, and we don't do any segmental line tunnels without fibre reinforcement, and we're now at the cutting edge with the Westgate tunnel, which is basically a 16.6 metre diameter tunnel, 500 thick, using fibre reinforced only solutions. As we've got a lot to catch or go through, and there's a lot of interesting stuff with the design, I'll just touch quickly on a couple of Asian projects, which is really good to see that in Asia we are now really starting to penetrate with fibre reinforced, and Singapore and Malaysia are certainly leading the way in Asia. And just to touch on a couple of projects there, you can read through the project information. And why we've shown these is 5.8 to 6.5 metre diameter are commonly used in metro tunnels. So this is a perfect application for fibre reinforcement, and certainly fibre only in most cases. Another project is the Thomson Line 2 T206, which was done in 2014. Again, 5.8 metre tunnel. And a more current, or that's just some photos of the segments, and you can see how there's absolutely no fibres on the surface at all in any of the photos that you can see there. And a more recent project, which is always really interesting, is a deep sewer tunnel in Singapore, and we're currently supplying 3.5 metre and a 6 metre internal diameter. And again, you can see very little to no vision of any fibres on the surface. And just a couple more photos from that project. I just wanted to touch on very, very quickly, Bekaert, when we win these projects, we design and install or help to install our dosing equipment, which helps distribute our fibres in and helps mixing and distribution of the fibres very, very well. So we offer that service free of charge, and we work with the concrete suppliers and the contractors to install this equipment. So on that note, I'll hand over to Gung to continue on to discuss our QA/QC of fibre reinforcement, which is really important to ensure for the engineers and the likes to get high performance concrete.
Hello, everyone. Yep. Let's start with QA/QC of fibre reinforced concrete. There are two main QA/QC that we do, and the first one is fiber dosage checking, as you can see with the equipment here, and it's under the standard SEA 14721. What happens is that you pour the wet concrete with fibers into this equipment, and the magnet in the center will catch all the steel fibers, and with that you can easily weigh it and find out what is the dosage of fiber you use. And this test takes no more than 15 minutes. The traditional way of washing by hand will take at least 30 to 40 minutes. Next slide, please. And then the second test that we should do on a daily basis is a beam test called SEN 14651, and this is the setup for the beam test. It's a beam with a notch at the center, and underneath the notch is a crack mouth opening displacement transducer, and it measures the opening of the crack mouth. So from this test, you will be able to get, next slide, please. Yeah, so from this table, you will see different projects, and you will see the numbers LOP, FR1, and FR4. So the earlier beam test, you will be able to get these values, LOP, FR1, and FR4. And these are the different LOP, FR1, FR4 for the different projects that we have had in Singapore and Malaysia. Next slide, please. Yeah, so these are the different LOP, FR1, FR4 for different projects. KVMRT is in Malaysia, T316 is in Singapore, and then Cheng Interterminal Board Tunnels is in Singapore. So all these numbers come from one single beam test. And it is very important to do this beam test because otherwise we don't have the design values. Next, please. Yeah. So the test will give you a curve like that. This is the load versus crack mouth opening displacement curve. And from this curve, you can get the three values, LOP, FR1, and FR4. Traditionally, the old way of fiber reinforced concrete is that you only have one value, and they call that a toughness value. That toughness value is easily cheated in a test, and because it's only one value. This test, you need three values from one test. So actually in this testing, there is no more way to cheat. You can't cheat anything anymore. Next, please. Yeah, then the proper equipment to do the beam test should have a rigidity of the loading frame of between 2 to 3 meganewton per millimeter square. Not per millimeter, sorry, deformation. And we have to ensure that the laboratory have such a rigid loading frame. Without this type of loading frame, we will not be able to do the test properly. So in the early days, one of the difficulties is finding loading frames with 2 to 3 meganewton per millimeter, but nowadays these frames are available everywhere. Thank you. Next, please. So this is some examples of pre-construction trials for the Singapore projects. This one comes from Circle Line 6, C882 and Contract 885. And you'll see that they do 20 beams for each batch, each trial mix, they do 20 beams. And you need to get 3 batches in consecutively days of testing, and all 3 batch must pass. All 20 beams must pass 3 times. It means if you pass batch 1 and you pass batch 3, but you suddenly fail 1 beam in batch 2, you redo all 60 beams again. So this is very, very stringent requirement. Why stringent is required? Stringent is required so that the consultants who are using these values for design can sleep well. Because if they only test 3 beams or 6 beams, you cannot show repeatability. Why they are doing 3 batches is in order to show repeatability. Next slide, please. Next slide, please. Yeah, so this is batch 2. So you can see the values are able to pass every batch, and all beams are passing. So if 1 beam in this batch fail, everything fails. Yeah, so testing is so important. Before we even start designing, we need to be able to make sure that our laboratories can test and they can pass every day. This mix must pass every day. As long as one of the beam of 20 here fail 1 time, it's out. So you redo your 20 times 3 sets again. So it's 60 sets. In Singapore, the cost of 1 beam is $1,000. So 20 beams is 20,000 times 3 times is $60,000. Yeah. So that's just for 1 trial mix. Yeah. Normally, for a project like Metro, you should do at least 2 trial mix. 1 is daily usage trial mix. 1 is a spare trial mix. Next, please, Brett. Yeah, so this is batch 3. And then next. This is trial mix 2, batch 1. Next, please. Trial mix 2, batch 2. Next. And trial mix 2, batch 3. So you see, in one project, they have to do 120 beam tests. Yeah, so that's $120,000 down the that you have to pay before you even start casting. Yeah, so but it's so important because it gives the designer peace of mind. The consulting engineer who is doing the design can sleep so well after this. Yeah, next please. And design wise, we can go to ACI 544.4R, published in 2018. Yes, so nowadays there is a book that you can use for design. So next please. And here you will see why the values are so important, FR1 and FR3. The stress at serviceability limit state, FFTS for fiber reinforced concrete involve FR1. The stress for ultimate limit state involves FR3 as well as FR1. So the bending moment for fiber reinforced concrete in serviceability limit state involves FR1. the bending moment for fiber reinforced concrete at ultimate limit state involve FR3. So as a result, it's so important that your beam test is getting repeatable FR1 and FR3 or FR4 results. Why? Because the consultant must be able to sleep well. Otherwise, they should not even consider designing fiber concrete. Next, please. Yeah. Then here is an example. Once you know your FR1 and FR3, you are able to calculate your stresses, and then you plug in your values to the moment calculation, and you can calculate your bending moment as well. So after this, you compare with your analysis, because you analyze your tunnels already. Your analysis will have the analyzed bending moment. You compare this bending moment with your analyzed bending moment. If this one is higher than your analyzed bending moment, you're home free. You're safe. Next, please. And then if you want to use a hybrid segment, that means rebar plus fiber reinforced concrete. ACI 544 allows this as well, because there's a section on hybrid reinforcement bending moment. So the hybrid reinforcement bending moment is bending moment for reinforced concrete plus bending moment for fiber reinforced concrete. So two terms are added together. So you can see that the bending moment for reinforced concrete is as shown here. These are based on how much rebar size you're using, how much rebar area you're using. And then the previous slide will give you the bending moment formula for FRC. So in this case, you are able to design hybrid segments rather than pure FRC, because the previous one is pure FRC. So segments in Japan, all segments are designed for this hybrid. Yeah, fiber concrete is also used in Japan, and because of seismic conditions, they always design segments in Japan to be hybrid. So for Manila, I think Philippines is a seismic zone, so maybe you might want to consider hybrid design instead of pure SFRC. Next, please. And then you see, you can even use it for shear design. If you have your FR1, FR3, or FR4 values, you can plug it into this shear formula, and you can get your shear for FRC. So ACI 544 is fully prepared for you to use to do your design for FRC segments. Actually, all you need to do is you do your usual analysis, and then you do the testing to make sure that you're getting the FR1, FR3, or FR4 that you want, and you plug it into these three formulas, and voila, you will get your FRC segment properly designed, either pure SFRC or with hybrid with rebars. Next, please. I think this is the last. Yeah. So this is the last slide. There are other guidance documents for the design of FRC. The first one is from RILEM, that's European, published in 2000. But nowadays, most of the standards or guidance document is using FIB Model Code 2010. And then there is also a Swedish standard published in 2014, and ACI published in 2016, as well as just now what I show you published in 2018. And then there is the ITATEC guidance document published in 2016. There is the British Standard document published in 2016. The FIB Bulletin published in 2017. And ITA Report 22 published in 2019. And in 2020, you will see our Singapore Standard Design of Fiber Concrete Structures being published, I think, at the end of this year in December. And all bending moment calculations in all of these guidance documents here, shown here, are using FR1 and FR3 or FR4 in the calculations. And these values come from the flexural beam test that you saw just now, which is BSEN 14651, whereby you need a good loading frame of between 2 to 3 meganewton per millimeter to be able to conduct the test properly. And this test, if it's producing inconsistent results, structural engineers cannot produce structurally sound designs. So that's why we want it to be repeatable. And I think the next speaker is Jeremy, and he will take over from here. Thank you very much. Jeremy.
Is Jeremy there, Abby?
I don't see Jeremy.
No, Brad.
Abby, well, maybe I can just talk on behalf of Jeremy if you can't get hold of him. Is that okay? Hello, Abby.
You're good, Brad.
He's logged in as JagCon. Can you see him in there anywhere? He's in there. I think you might just need to release him. It's under JagCon. Abby, give me some guidance here, otherwise I'll just start talking and just going through this project. But
Please, Brad, please start your presentation.
okay, I'm sorry that Jeremy can't get in, but this project is a metro project started back in 2015 with the Northwest Rail project that basically went from Castle Hill into Chatswood. This actual project is driverless trains. It is now operational and working, and we've currently under construction from Chatswood through the greatest CBD of Sydney and out to Marrickville. I've got the next slide is a quick video just to give an overview, which is an interesting video because it actually shows the pouring of fibre reinforced concrete segments in the precast factory, and yeah, just have a bit of a watch. Okay, Abby, Jeremy just tried to log out and log back in. Can you see him now at all to release him?
No, Brad. I can't find Jeremy.
Okay, so the important part about this project and the reason why the contractors like our products so much is obviously the quality of the segments, the reduced production area, project program and time frame. Obviously, in a lot of these projects in very built up areas, it's really important for the contractor to come in, produce the segments in an area that can be easily accessed for the tunnel boring machines and get the production done and out. And obviously in Australia, obviously our workforce is quite expensive, so reducing the amount of workers in the precast segment factory is very, very important to them, because obviously workers, if they can reduce the amount of workers in their precast factory by not using cages, it dramatically reduces their cost structure. This is just an example of the precast factory mobilisation, and I'm sure, unfortunately, Jeremy would have given a lot more of an insight into the factory itself. It's a carousel factory. Obviously, repeatability and traceability and turning over the molds is really important, and obviously a dual carousel in this case was important to produce the segments, which was 99,000 segments in a very, very quick time frame. So this is a picture of the precast factory, I believe, at Kellyville, which is the Northwest Rail project. So you can see it's a fairly substantial project, and you see the main building in the middle is two carousels, one either side, and the centre section is the concrete batch plant that services both sides of the carousel, and obviously the laydown section of the precast plant. And I can probably speak for Jeremy, is a lot of the time, a lot of the work is required in the factory setup and the commissioning and ensuring everything works extremely well before you really start mass production. And some of the learnings there was the time frames were very, very tight. So sometimes we're producing segments before everything's commissioned and working to its optimum. And obviously, like any factory, it's the mindset of the workforce to produce high quality segments, and obviously trying to reduce the turnover of the workforce is incredibly important. And obviously there's some incentives there that the contractor gave to the workforce to produce segments of a high quality and in a safe and quick manner. Obviously, you saw in the video how easy it is to cast fibre reinforced concrete, because it's all mixed within the concrete matrix, and it's distributed and vibrated and compacted in one quick and easy process. And then there's a couple of finishing stations, and then it goes into a curing chamber. Obviously, you also saw that there's barcoded quality control, QA/QC, which is also very, very important for the contractor and obviously the client as well. Just some lessons learnt. Obviously, water cement ratio is very important for the overall strength of the concrete. The moisture control is key in the concrete batch plant, because we're talking about very, very low slump concrete. In this case, I think it was about 20 or 30 slumps, so very, very dry concrete. So it's really important that that water cement ratio and moisture control is very much controlled. And obviously CCT footage and PA systems is obviously for safety and because there's a lot of moving parts in the carousel, and obviously for the contractor, the safety of their workers was paramount. Certainly in Australia, that's of the utmost importance. So, and also the layout of the factory and the yards to limit the movement of the segments and potential damage of the segments. So a lot of thought process, I believe, had gone into it from Northwest Rail into the Sydney Metro project that is now all but complete. That's just the completed tunnel. As I said, Northwest Rail has been in operation now. The first stage has been in operational now for a good 12 months, and everything's working exceptionally well. And just another photo of this completed tunnel before the tracks and track work has gone in. On behalf of Bekaert, I'd like to thank our key partner, Maccaferri in the Philippines. They're our point of contact for anyone in the Philippines to make contact with Neil and Thomas, the country manager. If they're interested in more information, Neil is our guy who we work with and we partner with. It's always very important to have a key partner in all the countries that we work in. So please, we appreciate the time, and I apologise that Jeremy couldn't get on and certainly provide more information from a contractor's perspective. And obviously, if there's any questions that you would like to know from Jeremy, I'm sure we can address those over the next week. And I'm sure Jeremy apologises, and we'll be able to help anyone that needs some further information. So James, I'll hand that back to you now, if you'd like, for any questions for, I guess, for myself or Gang at this point, and for Jeremy, any questions we can address in the coming week. So thank you again for the Philippines Tunnelling Society.
Yeah, thank you very much, Brad and Gang. It's excellent presentation. I've learned a few things, even though I've been using steel fibres for probably one and a half, 2 decades. So I think I see Gang has been very busy answering all the questions. So let me see which ones he hasn't answered. Oh, my second one. What's the cost comparison between traditional rebar and fibres? Has anybody done any studies on that to show the advantages in terms of cost? I see further down, Gang answered my question on carbon footprint, and he says there is a 20% carbon footprint improvement in using fibres, which is really interesting. So I guess there must be a reduction in the use of steel rebar compared to fibres. Maybe somebody can elaborate a little bit more.
I guess, James, that's a very difficult question to answer, because each country is certainly different. But I mean, if you take into the overall global effect of saving from labour, potential damage of the segments and throwing away of the segments, the installation damage, and then the cost of repair over a long period of time, and then what is the actual, is the repair going to meet the required design life and without actually intervention again, which is really critical. If you purely looked at just replacing rebar with steel fibres in concrete, there's no advantage. But if you look at a holistic of the whole project and the savings that you get, then there is a significant saving to be had, certainly for durability as well. Does that help answer?
Yeah, no, that's I think you've probably hit the nail on the head there, or from my perspective, you have, because the repair of segments after they've been installed in the tunnel and things like that, you know, and particularly if the segment's been cracked on the corner and it's moved the gasket and then it's starting to water leak, and then you've got to start to do resin injection, then that can become very, very costly very, very quickly. So yeah, no, that's good.
But if you, I guess, if you lose the cover, the 30 mil or the 40 mil cover as a designer, then you need some sort of reassurance or guarantee for that segment that whatever that repair is still going to give you your 120-year design life with a reduced cover. That's the important thing. Agree.
Yeah, that's good. Thanks. Great. Okay, so this is an interesting one. The sewer tunnel segments, do they require an additional internal layer? Gang saying no, they just need a sacrificial layer. Okay, so I guess that's the aggressive liquid that's attacking the concrete, and then I guess you assume that a certain amount of concrete will be destroyed over the 120-year life. Is that correct, Gang?
Can I just answer that question, because we did a study for the Adelaide desalination plant, which had a sacrificial layer of 20 mil over 10-year design life.
Okay.
After 5 years, SMEC went back in, which has just happened last year. SMEC went back and did a investigation of what the surface loss they have achieved after 5 years, and it actually turned out that they hadn't lost any surface loss after 5 years, and it's predominantly due to the durability, the high performance of the fibres, which dramatically increased the durability of the concrete. And obviously the durability consultant did a very good job in his design. So actually we can achieve some pretty great results, certainly in high brine areas with the outfall and infall of a desalination plant, and to achieve virtually no surface loss after 5 years of operation. I think we can achieve good things.
Yeah.
But yes, certainly a sacrificial layer in the design is certainly something that works as well.
That's a good, yeah, that's very interesting information about SMEC re-entering those tunnels after 5 years and finding no degradation. That's really good. Okay, I've got a question from Marlon of Manilad. Hi Marlon, long time no see. Conventional rebar prices fluctuate with the global price of steel. Are steel fibres hedged against steep fluctuation? Or you just buy on demand, or is it just?
Look, we although Bekaert is a very large organisation in the scope of steel purchasing, we're still quite a small supplier. So again, we try and buy as best we can. Because we obviously buy a raw material and we convert it into a product. So
yes,
we are susceptible to global movements of steel, and obviously we're highly reliant on China and what China does, like all aspects of construction, and we try to do our very best to limit the impact on projects and on our project pricing, but again we are also relying on what the global market is doing at the moment. And obviously with COVID happening, we've in our plants we had to put safeguards in there, which was some costs, but I mean we are still very competitive in the market, if that answers your question.
Yeah, that's great. Yeah, no, thanks very much, Brad, for that. That's good. I think from what I see, Gang's pretty much answered all the other questions as you've been talking, Brad. So he's been helping us with all that.
Excellent.
I'm just trying to see if there's any other ones that I can pick on. Maybe we just have one or two more. Yeah, I know. I was very interested in Gang's talk about the use of the concrete code, particularly the ACI code, which is good because a lot of countries have been really struggling to allow the start of using fibre reinforced segments, particularly in Hong Kong, because they always want a design code. But now we have actually got something. It's really good, and hopefully that'll bring it forward.
James, we're actually supplying a tunnel in Hong Kong right as we speak. So
good.
Yep. And I know Gang has supplied tunnels in Hong Kong over the years, so it's not really new technology for Hong Kong either. Gang, you.
It depends if it's sprayed concrete. Because of the sprayed concrete, we're not allowed to take the strength of the fibres into account in the temporary works design. But it's changing. It's changing. Gang.
We're actually doing tunnels now in Australia, James, with temporary shotcrete, sprayed shotcrete, and also permanent sprayed shotcrete with steel fibres now as the final lining.
Brilliant. That's really, really good. Yeah,
so
that's excellent.
The M4, the M5, and now the WestConnex 3A and 3B are all steel fibre primary shotcrete and also steel fibre final liner with micro PP fibres for fire.
Yeah. Oh, that's really, really good. I think that also saves a lot of concrete as well. If you can start combining the temporary with the permanent support, that's really, really important for us. Yeah, that's great. Anything else you'd like to add, Gang, before we close?
Oh, nothing for me. I already answered all the questions. You can
I can see that.
The answers and send it to everybody.
Yeah, yeah. We'll be uploading the presentation. Hopefully, I'm not sure whether I think we upload the live event as well, so they should be able to see the Q&A answers in the column as well.
All right.
So that's great. So on behalf of everybody, all the listeners, thank you very much to Brad and gang. Unfortunately, Jeremy couldn't connect. I think we need to plan that better for next time. There must be some technical issues with linkages, or we started the live event or something like that. But no, overall, very, very good presentation. Very good to see the technical side on how we can go forward and use the fibers in our design, and also the quality control issues, how they can be resolved and proven, which is very important. So yeah, on behalf of the Philippines Tunneling Society, thank you very much to you both, and hopefully look forward to seeing you hopefully in the new year, when COVID is removed and we can get back to some normality and have some beers together.
We both look forward to that that day, James. So thank you again.
Yeah, thanks very much. Okay, Abby, over to you. Any final words, or we can close? Thank you very much.
Yep, thanks everyone. We will be posting the video and the presentation on our website, so please check them soon on www.fieldtunnel.com. Happy weekend.